Hi, good afternoon, everybody. My name is Professor Bill Brown, and this is the practical using MLWin that goes with our learning materials on cross-classified models. So you should have watched 3 videos, 2 by myself and 1 by Professor George Leckie on cross-classified models. And in those videos, we covered a particular practical example, which is the Fife dataset from Scotland. And in this talk, I'm just going to go through, taking you through the practical that goes with it. So you can see on the screen here, chapter 15, this is my NCRM manual for the MLWin software. And this chapter, this goes through cross-classified models. So the first couple of pages, as I scroll through here, cover a lot of the material that we'll have covered in the lectures. They give definitions of things like classifications, they talk us through notation, and they even give us a little bit of background on the Fife dataset. So I'm not going to scroll through this all the time. What I'm going to do is I'm going to start up the MLWin software, and I'm going to work my way through this practical while you can watch. So if we go on our start menu, Center for Multi-Level Modeling, there should be MLWin version 3.05, which is the current version. So I click on that. And any minute now, the MLWin software will appear. Okay, it's slowly starting up here. I think because I'm recording at the same time. And here you will see the MLWin software. Hopefully you can see that on the screen. So I'm not going to show you the text while I do this. I'm just going to follow the instructions. So the first thing, we've brought up MLWin. The first thing we need to do is we need to open up the worksheet. Okay, so in the instructions that you have for that chapter on cross-classified models, they will, in boxes, they will tell you what to do, and I'm just following those there. So if we go open the sample worksheet, in the list that appears, we choose xc1.ws. So that's the Fife dataset in Scotland. And when you open it up, what it does is it creates this names window here, which gives you a list from the top to the bottom here of the 11 variables in this dataset from Scotland. It talks a little bit about those different variables. You'll have come across them if you've looked at the lectures. So let's go straight on and choose from the data manipulation menu, view or edit the data. And that gives you all of the data. And it specifically asks you in the instructions to choose some columns. So attainment, primary ID, secondary ID, and pupil. Okay, so in MLWin, that's basically just shortened to 4 columns. There's the 4 variables. So what we see here, I've moved it across to the right-hand side of the screen. Here are the attainment scores. So the first individual got a score of 2, and that's an individual in the first primary school, or primary school 1, and secondary school 1. And then pupil, their pupil 39. The pupil ID is a kind of an arbitrary number in some respects. And we come down here, the first 8 are all in primary school 1, and then we have some in primary school 5, and so on. You'll think, well, is this data nested or is it cross-classified? So if we follow the instructions, if we were to go to line 1355, okay, here we see some more primary school 1. So there's some individual pupils in primary school 1 who went to secondary 1, but these ones here go to secondary 9. So this shows you that we have a cross-classified structure. So the first thing we do next is we try and set up some equations to fit the model. So we go to the model menu, we choose equations. There is the equations window you can see there, and I follow the instructions. The first thing I do is click on notation. And because we're doing cross-classified, we get rid of what we call a multiple subscript. Click on done. And you can see that we've just got now an I subscript for Y, our response variable. So I'm going to set up my model. What I'm interested in is these attainment scores of the children at age 16. So I choose attain as the Y variable. I choose 3 classifications. I'm going to choose them in the order of secondary school as classification 3, primary school as classification 2, and pupil as classification 1. So I click done. That's that bit done. I now need to specify the right-hand side of the model. So I click on the red X node. I choose cons, which stands for constant. It's just a column of 1s. And I'm going to say, to start with, let's just have a model with secondary school and pupil. Okay, and I click done. And I can click, if I click the estimates button a couple of times, here we have a full description of the model. Okay, and if I follow the instructions, if I click start, this will fit that model in a classical framework. Okay, we're using MCMC for much of what we're doing. So if I go to estimation methods and click MCMC, it gives me the different things that I can change there. I'm going to keep them as default, and I'm going to click, close that actually, I'll click start, and away we'll run the MCMC. You'll see the numbers are changing. Actually, if I get rid of some of these windows, let's close the names windows. Okay, and it's finished. Down here we can see actual updates 5,000. So that's run for 5,000 iterations. I click plus, we get the full model description here. So we have a model, okay, with 3,435 observations, 19 secondary schools, 303 primary schools. And you'll think, well, that's a bit odd. The actual data has less than that. And what this has done at the moment, we haven't fitted primary school in the model anyway, but it's nested primary schools within secondary schools. So every time it comes across a unique ID, it will call that a new primary school. Okay, but ignore that for the minute. At the moment, what we've done is we fitted the model with just secondary school effects. Here's the model. Okay, we can see the average attainment score is 5.6. There is some variability due to secondary schools and some unexplained variability at the bottom. And we can use MCMC DIC diagnostic to give us some measure of how well that fits. Okay, so there we can see our DIC criterion 17309.99, and you'll find that number in the chapter as well. If I was to refit that model without those secondary school effects, I can do that by changing back to the Eagles algorithm, so the classical way of fitting them, and just coming back into cons and removing secondary school for a minute. Click start, fit the model using MCMC. So I've changed estimation to MCMC and clicked on start. Okay, and that model fitted almost instantaneously. So here's a model. That model just has the attainment score and some variability. Okay, we've got no levels in the model. And I can get the DIC diagnostic for that. 17431. So we can see that that has dropped when we fit the model with secondary schools, and so that's a better model. So we find that actually we do need to include secondary schools in the model. But that's just a nested model. What we're interested in is a cross-classified model. So if I go back in again, I change back to Eagles. So every time when we're fitting MCMC, we have to go back to the classical methods, just simply to change the model, simply because we need to get new starting values for our MCMC methods. So I click on beta 0. Okay, I'll put secondary back in, and following the instructions here, I click on PID 2, and now I have this structure with, if you look here, the attainment score is some constant, some effect for secondary school, some effect for primary school, and some level 1 residual. Okay, so there's where we've got now. If I was to look at, so if I was to go model hierarchy viewer, we can see quite clearly that in this model it believes there are 19 secondary schools and 303 primary schools. But actually we know in the data set there's only 148. So every time it comes across a new ID at primary school, it believes that that's a new primary school. So every time, so the pupils who go to secondary school 1 and primary school 1, that's thought of as primary school 1. The pupils who go for secondary school 9 and the primary school 1, that's thought of as a different primary school 1. So that's why this number is 303. So we have to tell, so if I run the model first with equals, okay, and then if I go in and go estimation methods MCMC, okay, I can go in and go MCMC classifications, and now I tell the model that actually my data is cross-classified. Okay, I click on that and I click on done. Okay, lots of things disappear. Okay, and now if I bring up the hierarchy viewer, we get a different thing here which talks about the different classifications, and now it's correctly identified that there are 148 primary schools. Okay, and if I come down there in the equation window, we also see that there are 148 primary schools. So I click start, that will fit that model using MCMC. And what we will see now is that we will get different variability. So we can see actually primary schools explain much more of the variability than secondary schools, about 3 times as much here, 1.2 nearly to 0.4. Okay, and is that a better model? Well, let's first off just check about, let's look at the trajectories plot, because that's what it asks us to do in the manual. So if I go to trajectories, okay, this is just showing me how well the MCMC is doing. And if I look at the secondary school variance, so I just click on that trajectory plot, okay, there is a plot. Okay, so we can see really that there is some variability, okay, and that's a reasonably well converging chain. We have got quite a skew distribution. That's because we only have 19 secondary schools. Okay, so if we were to now just say, well, is this a better model? So we can do that via DIC again. So if we go MCMC DIC diagnostic, now we can see that the DIC has dropped to 17047 compared to 17309. So that's a better model. Okay, so we've got a better fitting model. We can look at other things in that model. We can look at residuals. So if we go model residuals, we can choose the level we want to show them residuals. So if I look at level 3, for example, click on the calc button. And then if I go to the plots, I can look at residuals versus ranks. And if I click apply, here is a diagram. Okay, so we can see here a triangle for each of the 19 secondary schools, and they've been sorted from the worst performing to the best from left to right. And this one, the worst performing one, looks a little bit of an outlier. It's got a very low residual. If I click on it, it tells me actually that's school 19. Okay, so we'll come and look at that a bit more later in this practical. We can also look at the primary school effects. So if I go back on the residuals to the settings tab, I can change from secondary ID to primary ID. Again, calc, okay, and plots and apply. Here we have the graph of the 148 the triangle for each primary school. And we don't really have any evidence so much here for outliers. Okay, so we can click on, for example, the lowest ID here, and we can see that that's primary ID 139, for example. So we can do more things like that. What about having a slightly more exciting model? So if I close up some of these windows, let's close up the residuals for now. I'll go back to Eagles because I'm going to change the model. And I'm going to add a term, so I'm going to make the attainment scores depend on VRQ. So VRQ is a verbal reasoning test that was done at the start of schooling. So I can start that to give me some starting values, and then I can change to MCMC. And it remembers that we're doing a cross-classified model, so it immediately goes to 148 primary schools. I click on start, and you can see the counter ticking away in the bottom corner. Okay, and that's finished. We're not going to we're not getting too involved in how long should we run for. We're just going by the defaults. That's not what you should do in practice, but in this case, it doesn't matter too much. In practice, you should really just check that your model has converged properly. Okay, so here we can see the model. We've got a strong positive effect, 0.160 here for verbal reasoning score. So every 1 extra in verbal reasoning score, your attainment goes up by 1. Goes up by 0.160, sorry. So we can say, is that a better model where we do the DIC again, and they're all coming up here, and DIC has dropped quite dramatically there. So VRQ, that's really explained a lot of the variability. Okay, and now what we can see is really of what's left, about 6% is here, this value here, 0.278, so about 6% of the remaining variability is due to primaries, and only about 0.4 is due to secondaries. Okay, so I could carry on like this. I could try all of the different predictors. I'm going to do them all in one foul swoop here. I'm going to add in several terms. So I'm going to add in social class. And I click on add term again, and I'm going to add in father's education. And I'm going to add in mother's education. And finally, I'm going to add in choice, which stands for school choice, as to whether this was the first choice of school for the child or not. I'll start that using equals to get the starting values. I'll change to MCMC and I'll click start again. And again, I've got a slightly more complicated model, so it'll chug away for a little bit. Okay, and then it's finished now. So we can look at these predictors, and we've seen this in George's lecture. Verbal reading test is still very high, very significant effect. Social class, the higher the social class, the higher the attainment. The higher the father's education, the higher attainment. The higher the mother's education, the higher attainment. And if you don't get your first choice school, so school choice is 1 for first, 2 for second, and I think that somebody was very unlucky and got 4th maybe, then you get a negative effect. So not going to the school you want to has a negative effect. Okay, so that's interesting. We can look at the DIC for that as well. So if I do MCMC DIC diagnostic, and we have dropped again. We've dropped not quite as dramatic a drop as when we added in verbal reasoning test, but we've dropped from 14,805 to 14,728. Okay. We can look at the residuals again in this model now with these additional terms in it. So if we go to level 3, calculate, and if I plot that graph of the residuals again, if I click apply, okay, we can really see this drop here between this school, which is still school 19, and the rest. So the question really is, looking at this model here, really, is that little bit of variability left in secondary schools really just a difference between school 19 and the rest? So what can we do about that? Well, if I go under data manipulation, there's a command interface window, and in here I can type a command. I'm going to type calculate C12, so it's a new column, okay, is equal to school ID, in quotes, double equals 19. Okay, and what that's going to do is it's going to generate a column. Click OK, so that seemed to work okay. And I'm going to name C12, quotes again, school 19. Okay, so I could look in the data, and if I view the data, there's school 19 has occurred there. What we'll find, let's drag this across, you can see lots of zeros, and at some point we'll get to school 19. It'll be right down the bottom. Okay, we've got 1s for that. So it's a dummy variable for school 19. Okay, so we're going to use that to compare the model we currently have with a model where we just put in a dummy for school 19 and don't put in secondary school. So let's change the model to look like that. So I go back to Wiggles. I'm going to click on the cons here, and I'm going to remove the school IDs. Okay, so they've vanished, done. And then I add term, and I'm going to add in school 19. So rather than having a random effect for each school, what I have now is just a fixed effect for school 19. Okay, so I click start, get some starting values, I change back to MCMC. Okay, and click the start button. What you'll notice in MLWin is that windows appear to jump around when things are up, when you press buttons. Okay, so there we go, that's finished. And so there we can see the output, the numbers. And what do we see here? Well, we can see school 19 indeed has a strong negative effect. We were expecting that. Okay, we don't see much difference to the other effects here. And the variance 0.209 for primary schools is very close to the 0.206 that we had previously. Okay, in actual fact, the lower level variance is 4168 was 4171 before, so we've not really changed much at all there. If we look at the DIC diagnostic, okay, what do we see? Well, actually, if we compare this model with the last one, it's actually moved down ever so slightly. So we've got a slightly better model here. So really, what have we done there? But we've said that we started off with a cross-classified structure, and it was really important to have both secondary schools and primary schools in there. Then we've added in these various predictor variables. And when we've done that, that's been enough to explain some of the differences between secondary schools. In actual fact, what we were left with was really just a discrepancy between one outlier in secondary school, school 19, and the rest. So if we instead just put a dummy fixed effect for that school, we get a better fitting model. And now we no longer need to do a cross-classified model. Okay, which means actually we wouldn't have to do the MCMC estimation that we do, and we could go through the standard Eagles algorithm. So I think that's all I'd like to say here. That's the end of the chapter. Okay, so hopefully that it shows you a little bit of how we can do cross-classified models in MLWin. So thank you very much for listening, and I hope you can follow that yourself at home with the manual chapter. Goodbye.